So I'm not going to do too many formalities since we're running behind time, and it's a pleasure to have Professor Soni talk about his work, and I'll open the floor to him.
Okay, so I was told about 40 minutes, but let's see, we'll try and move a little faster. When I began this, there are several things that we've done which use these things and which are different solutions for different things. I thought I would talk about two things which are very relevant in India right now, because we are soon going to have a pretty grim water situation with the fact that most of our water sources have got polluted. And how can we deal with this? Do we have any solutions? And so let me just start. So these are two conserve and use solutions that I'm going to be talking about today. If you want to look at details, we had started a foundation called the PI Sci Foundation, and I'd like people who are joining us, especially the young minds, to actually look at this site. It's called scienceandpublicinterest.com. And you'll find a lot of written articles, both scientific articles, and we write only in current science by and large. Very few things in international journals, because we think that it's a good idea to encourage local journals. But many things in the newspapers, you'll find videos, you'll find TEDx events and things like that on this thing. So I'm going to talk about these two. So please, here's my email and number, and I'm hoping that some of you will get enthused to start working with us.
Yep.
Okay.
Go ahead.
It's working now. But you'll have to move it, I think, then, huh? I can't.
Just tell me when to do it. I'll just click. Yeah.
Okay, just carry on to the next one. So I already said that this is, well, okay. The first one just gives, the address and things like that. So let me start. See, one thing you realize is that if we want to work with the planet, and the planet is in great jeopardy today, we need to know how the planet works, right? It's a very obvious statement, but unfortunately, all our science and technology has been completely contrary to that now. Okay, we have never actually respected the planet. Okay, so the next one. Let's just a few introductory remarks. Why am I talking about water? Because actually what we want today, we find, is quality of life. We might have incredible luxurious things, standards of living, but quality of life is a disappearing thing. It's becoming rare, at least in Indian cities and over a lot of the country, not just in the cities. So you want good natural air, you want natural food, natural water, natural soil, and all these things are disappearing very fast. And the paradox is that for all this, technology is being marshaled. So we have a purifier for air, which now everybody is trying to, can afford it, is trying to get in everybody. You can't afford it, of course can't. We have purifiers for water. We need air conditioning to combat global warming. So a huge amount of technology is being marshaled to just deal with these problems, right? And this is, where have these problems arisen, including the problem of global warming and the pandemic, for example? These are problems of unrecycled waste, as you know, with plastics and things like that. And that's exactly opposite to the production systems in nature, which do not have any waste. Okay? All the waste is recycled, and that's how the planet has been working for 3 billion years. But we, in 50 years, have managed to more or less neutralize at least a large chunk of the planet. 60% or 70% of the ecosystems are in complete decline, and most of them are not going to come back. So we have to realize that our technology is such at the moment that artificial infrastructure, which is technology, kills natural infrastructure. So that was the idea with which we started doing these things, that can we use what nature gives us in such a way which is non-invasive, which is going to be perennial and for all the coming generations. Otherwise, we're not going to have all these things which have co-evolved with us over the last 3 billion years. The mineral water, the natural food, the natural soil, because we are now losing the balance with nature. So more and more technology is used to restore these essential services of life provided by nature. Right? And that kind of economics, which somebody was doing economics, is now probably going to be the largest one. Okay, we can go to the next one. And please stop me if somebody wants to ask. Next one, can we go to the next one? Next transparency. Okay, so I wanted to say that, Water Aid and the Niti Aayog and also people in India are aware of the fact that almost all our rivers and reservoirs and much of our groundwater, very large proportion of our groundwater, they say 75%, and usually government statistics, as you know, are usually understated. They say 75% of our surface water is polluted. It's polluted, and also 60 to 70% of our groundwater is polluted. So it's polluted. It's anthropogenic. It's human sewage. It's chemical effluents coming from industry and from agriculture, pesticides, and fertilizer. So here is a question we asked: what do we do now? How do we give people water which is healthful, which has some quality in it? Okay, can we go to the next one? The next one. Okay, this is just a picture of the floodplains, and I'm going to now try and show you how the floodplains in our rivers, and fortunately we have a lot of rivers, can still be a quality source of water. Okay? And a lot of this is available on the site, and if you Google it in newspaper articles. The next one. So this is from our papers that we are now getting. What happens is when you have a local water problem and your water becomes bad and your river becomes polluted, then you go far away and get your place. This has been the Western fix. New York gets its water from the Catskills, which are 300 to 200 kilometers away. London also gets it from far enough places. But we perhaps will not be able to afford to do this in India. So, because the river water, I mean, you'd be surprised that the Rhine, which is probably the most disciplined cleansing operation. When I asked the Germans who came here for cleaning the Ganga, and they were trying to bid for cleaning the Ganga, and I asked them, "Is the Rhine clean?" They said, "Of course it's clean." And then, the minister didn't come, so I asked them, "So do you drink the water from the Rhine?" And they said, "Of course not." So I said, "Are you going to tell them that?" He said, "Of course not." So, it's not easy, even if you cleanse a river, so to say, after 50 years, the Rhine water is still not drinkable. It's not potable. So that's how difficult it is. Can we go to the next one? So the next. So this is available in Current Science, which is the next transparency. Can we go to the next one? We'll have to go a little fast. Sid, can you hear me? Hello? Hello, Sid, can you hear me? Oops.
Can you hear?
Okay, there was one transparency in between which showed you the article in Current Science. I just want to see, this is an article from Current Science, which is
Is it the one? Sorry.
Yeah, this is
yeah.
the one. So the Current Science is given at the bottom, and that's the title of the article. And if anybody is interested, they could read the article. It concerns something called the Palla Project in Delhi. I'll come back to it a little later, which is providing water for about 1 million people, running at half its capacity. Okay, and that's where I wanted to make the point which I was making earlier, that science helps you in understanding what kind of resource you have, and to what extent can you use it without injuring it, without destroying it. Because it's the easiest thing to do is to destroy a natural resource, which is what we've been doing. Okay, so now you can go slowly. Next one. Yeah, no, next one. We have to go down. Okay, so what's a floodplain? Okay, so there's a kind of geographical view of a floodplain. Keep going. These are just pictures coming from a glacier. The next picture. Then you have the Yamuna, and it's coming out Okay, now we stop here. So what we did was, now here's an example of trying to do a simple experiment, which every villager understands and every physicist understands and every Nobel Prize winner will understand. Okay, and we have Nobel Prize winners who actually have looked at these things. So you just take a glass of Yamuna sand and a glass of water and up to the same level and start pouring the water, and you find that almost half the water gets into the sand, which you see in this picture, in the third picture. So what is a floodplain? The floodplain is a huge landmass of sand, and when water goes into it during the monsoon and when it rains, it fills up because there are lots of interstices, as you see over here in this experiment. And gradually what it does is it fills up all the pores in the sand, all the vacant spaces fill up with water. So the floodplain after that gets saturated with water. Now, what is the great thing about a floodplain as opposed to a lake? Well, there is no evaporation loss because it's all underground. And therefore, it's not very visible, which actually is a fantastic thing. But because it's not visible, a lot of people come and ruin it and destroy it. Okay? So it has immense value. So now let's go a little further. Next one. Okay, so why is I call this conserve and use natural recharge? Because the recharge is natural. It comes from rain and from late season floods. So both these sources of water are unpolluted. The rain is unpolluted, and late season the river actually is at its least polluted. And so the water in the floodplain is actually incredibly. It's pretty incredible. It's incredibly much better than the water that flows in the river. And we will get to the condition why this is the case. Can you go to the next one? So it has natural storage and it has natural recharge. Okay, next one. We've already seen this. Okay, so here are some of the features. If you withdraw water in a floodplain, you find that the movement of water in the floodplain. So okay, I should say one thing, that this floodplain, which probably wasn't shown there, in the Yamuna is about 5 to 10 kilometers wide. That is the area in which you have sand, and it's about 60 around the river for the next 1 or 2 kilometers on both sides. It's 70 kilometers deep. So sorry, 70 meters deep. So you can imagine what a huge source of water it is. Right? It's all along the river, which means thousands of kilometers. It's at least 5 kilometers wide and 60 meters deep, and about 35% of it is water. So that's the amount of water in a floodplain. That's why I was saying that the amount of water in the floodplain that the floodplain holds is at least 10 times the amount of water that flows down a river, the virgin flow of the river throughout the year, if nothing was extracted. So it is an incredible aquifer, and it's exceptional because when you withdraw water from a tube well at 0.3 million gallons a day, most wells will run dry within half an hour. Floodplain aquifers, you can run 72 hours. We did a stress test in the floodplain at this very high level of withdrawal, and nothing happens. Nothing runs dry. It's good. So hydrographs show that the draft area has only a 2-meter loss when it would have been 12 meters without any recharge. Okay, so the rest of the floodplain, which stretches all the way the length of the river, and the water flows immediately to recharge what you're withdrawing. Okay? The recharge, as you say, comes with annual flood. So it's natural storage and natural recharge. Okay, now that is the secret of the floodplain. That natural storage and natural recharge. So you really don't need to do anything much except protect it and make sure that you understand what it's doing. The quality of water is good because it's recharged from rain, which is not polluted, and late season floods when the river pollution has been flushed out. But one important thing, one absolutely sacred rule over here, and nature has many sacred rules, and that's where science comes in. You have to understand. is that the floodplain should never be overdrawn to keep the resource healthy and contamination. Because the water level in the floodplain must always be above the river level. You know, the river is very polluted, as you all know. So if the floodplain water level went below the river, then what would happen is that water from the river would start flowing into the aquifer of the floodplain. And once it's contaminated, it's impossible to get it back. So that's why I'm saying this is one of the things that is still left, that maybe 80% of our floodplains in the innumerable rivers in the country are still intact when you go away. And this is what we found just next to Delhi, north of Delhi. Whereas in Delhi, it is terrible. The river is just terrible. But a lot of the floodplain is unpolluted. I won't go into any more details, but this gives you an idea. Why is this the case? Because the water, if the water level in the floodplain is above that of the river in the lean season, when the pollution levels are very high, then what you find is that the water will flow from the floodplain into the river. And that's an essential thing, function of the floodplain as far as the river is concerned. It runs the river in the lean season. Okay, so you don't take out all the water that is recharged at the floodplain, but maybe take out half the water. Now, can we go to the next one? I'm going to do this reasonably fast. And please stop me or we'll stop at the end of this if you have any questions. Stop me anytime. Otherwise, there's no point doing this unless people understand it. So good, we can go to the next one. This is a picture of Sid, to the next one. Okay, here are the details of the Palla project. Palla is north of Delhi, north of Wazirabad, north of Delhi University. It's about the Yamuna in Delhi itself, not in the Palla project. It's about half of this. It's 25 kilometers in the north and it's 25 kilometers south of it. So altogether it's 50 kilometers and 2 kilometers wide on each side. Rainfall is only 60 centimeters a year. Flooding, there can be at maximum flood a 4-meter rise. You dewater 3 meters of floodplain, then what you can actually estimate how much water you are actually can pull out. And it works out very simply because, once you dewater 3 meters of floodplain, you can work out how much water you can take out, because that is the amount of water that will come back in the next season, roughly speaking. You have to be careful about the season. So about 100 million cubic meters a year is what is usable if you want to keep the floodplain going in a healthy condition year after year, year on year. And at 150 liters per day, this would give water for about 2 million people. And this is a well over there, which we just given you a picture of it. And we tried to put a computerized system there with the Delhi Jal Board. Unfortunately, the Jal Board made sure after that this will not work. So at the moment, it's still lying, and this computer system, which gives you, it's called the SCADA system, the supervisory control system. It allows you to take out water up to a certain depth. It keeps track of the depth of the floodplain, and it also looks at the quality of the water and things like that. All the sensors are attached to this. And it worked for a little while, but unfortunately at the moment it's not working. And somehow or the other, this is a great project of the Delhi government. And at the moment, I don't know what the Delhi government is doing, but they're doing some crazy things. I won't waste more time on that. I just want to show you that this can be done not only in all our cities, but all over the world. So let's go to the next transparencies, and we'll stop in a moment. Okay, this was the computerized system which will give you all the levels and the sensors and the quality and what is being taken out, but it didn't work very well. And the next one. So this is what happened when we did this, and this was 2016-17, that this was the first project of its kind, Conserve and Use in Palla. And it was reported in all the papers. It was also noticed by the Australian agency because they have problems with water. And this was a pretty amazing thing, which we thought would now spread to, where it would start protecting all the floodplains in the country, because it's very important to protect the floodplains if we want to actually even keep the river in clean. So we had suggested that the floodplains should actually not have any intensive water agriculture like paddy or anything built on them. And in Delhi, we managed to get uh, the floodplain declared a biodiversity zone. But nevertheless, as you know, in India, that these things come and these things go. And I was hoping that the government would continue to do this. It didn't. So now I want to just show you that we have a small plan on how to extend this and how this can connect the rural to the urban. So can we go through the next few transparencies? Next one, please. Okay. So next. So here's a floodplain land, and then you have cows grazing on it. So you have to lease the land from farmers and squatters, and farmers would be happy to get something like 30,000 to 40,000 rupees an acre per year. And in addition, they would be allowed to have food forests or fruit forests, okay? Either orchard or grow organic food. But that's all. But they will get this much, which is not what they earn. This is a guaranteed income. By supplying this much water, ecological quantities of water, to urban centers nearby. So we had proposed this for the river in Tamil Nadu, the last river of India called the Tambravarani. It has yet to happen, but it hasn't happened. But okay, we'll just go to the next few transparencies to show you what the idea is. Next one. Okay. So it provides the farmers an assured income, release the land, and ecologically supply half the water to the urban centers, which pay for it at the usual rates, which are already subsidized rates. But they give you a huge, fantastic income from this water. And it's good quality water, as I told you. Next one. So, can you go to the next one? Okay. So preserving the floodplain, of course, as I said, by putting food forest or fruit forest on the bank, if you do that, then the floodplains of all the rivers and the rivers can be can be preserved, because then people can't easily come and pollute it, whether it's industry or whether it's somebody else. And this is the last one. I'm going through them quite fast, but it just shows you what the steps are. Next one. Okay, so it's a self-sustaining scheme. It's totally non-invasive. It has natural recharge. It has um, um, natural recharge as well as natural storage. And the only thing is you have to make sure that it's protected, and protected means that you don't lower the water level below that of the river. Never. Okay. So I think this is the end of the just go to the next one. I don't think these are just simply steps. Yeah, please move. Okay. And the next. So it's self. So, once you protect the floodplain, then and you have food forest or food forest, then what happens is this is the best way to actually cleanse the river in any case, because then people can't come and pollute it. Okay. And the quality of the river might not be potable, but the floodplain will be, but the river will get better and better. And maybe after 100 years or 50 years, it might be okay, but at least you'll start getting fish back. And look at so the next one. So this has linked the rural to the urban. So the farmers who are having a very bad deal in India, as you know, if they were floodplain farmers, they can be assured an income, and they can be assured a production, including owning the land and having fruit forests, all the income from fruit forest and fruit forest. And the economics works out just perfectly. But unfortunately, we haven't been able to spread it. And if anybody, which people come from lots of places in India, I hope in your audience, they could perhaps use this, and we'd be very happy to give you all the details of how it's done. But just one more, next slide on economics. That if you looked at, if you invest 100 crores of capital for wells, pipelines, and the reservoirs are already there in a town and a SCADA system, you can actually pick up at commercial rates 1,000 crores of revenue. But if you give it at subsidized rates for water, which is given in the city, then you would still get about 200 to 300 crores a year, 200 crores a year. But at commercial rates, it would amount to that much. So economically, it is just fantastic. Okay. So what you're doing, you're giving 30,000 rupees an acre. I don't know if my arrow is working over there. And the operating costs are very small. And this is the revenue that you would get if you were to have 60 MCM, about half the amount of water. And you would make 200 crores. But if you sold it at commercial rates, you'd make more. Okay, now we go quite fast through some of these things. You know that India has rivers everywhere, so you know it's just Google map of the floodplain. Just keep going. Yeah, next. So this is typically what it looks like. And the next one is the Ganga, and there are many cities which could go on floodplain water starting. Delhi is a mega city, so you can't do water for more than 1.5 million people now, because the rest of the floodplain is already there are people, buildings on it, and it's sitting on it. But there are places like from Mathura to Agra to Allahabad to Varanasi, all these places down the line can actually all work on floodplain water. And it's not just in India, but there are many places. The next transparency. That here's the Tigris and the Euphrates in Western Asia, which have a continuous water problem. If they were to use the floodplains properly, that would be. Here's the Wang Ho river in China, which has huge floodplains and water problem. And you know, the Zambezi or whatever. Anywhere where you have a problem, this would be the best way to preserve the river and to save it. Okay, now I want to stop here for 2 minutes, and you know, I'm sure people have some questions. Maybe it's a good time to answer it, and then we'll just move on to the next one, which is a little shorter. So, are there any questions, please? No, we have to have questions, otherwise we don't have creativity and we don't have science.
Can I put forward one question, please?
Of course, of course.
Yeah, like you were speaking about the zero evaporation loss, how different is it from the rapid sand filtration, which is used on a large scale filtration of water from the river? I mean, is it very different concept, or is it's got to do something? I mean, it's quite similar. I just wanted a clarification on that.
Oh, okay. So see, the evaporation loss is completely separate because it's underground. It can't evaporate, right? Yeah. Usually, from a lake, you have about 2 meters or 2.5 meters of evaporation in a tropical country like this. But sand filtration will happen to all the water that comes in the rainy season and goes down the sand.
Okay.
And even from flooding. But that's a separate issue. I didn't come to that. That is one of the reasons that the quality of water in the floodplain is even better.
Okay. Yeah.
But maybe you have other questions also. You know, I mean, just the idea about how one is using science. This, you know, all this thing is actually, it's very difficult to get data because, you know, sometimes you have to go and take a bamboo stick and go down to the river in the summer to get the levels, take a boat and go there, and you know, it may be 1.5 meters because all the water is withdrawn from the river. So this way, at least the rivers will also run. And for the first time, I think somebody in the government seems to be talking about natural agriculture on the Ganges floodplains. And I hope we send all this to the government, but the government does not really be listening very much. And it's unfortunately stalled, although I know that I had somebody in ICTP in Trieste from China inviting me to China, the Chinese Academy of Sciences, to help them with their rivers. Of course, at that point I didn't go because I thought maybe we should firm up things in India before we start spreading it. But I think it was a bad idea. It's just a good idea to spread it. Right? I mean, the idea here is not to make money, although it's economically more than viable. But the idea is to give water and to get water and preserve the river and the floodplain as a resource for future generations. Sid, what about you? Any questions?
I definitely have quite a few questions, but I think we're running out of time. I will ask the last question and maybe Samit,
Okay.
what are we doing with the time? Do we have a time for
So
one quick short questions?
Yeah, please.
Samit, you're on mute.
Yes, I've been trying to talk about the time while you guys are talking. Sorry.
Sorry. Okay, so we don't have.
Yes, you have really. I mean, if you ask a really short one, then maybe.
So what we can do, maybe we can do questions at the end if we have time. Okay, so let's hold.
Okay. All right. So keep track of them. Let's finish off. Let's see, 10,
yeah.
12 minutes.
So my question was, I will just post the question and then maybe Professor Soni can answer at the end
tell me.
because Professor Suresh is also waiting. So
yeah, so maybe put the questions in chat.
Yeah.
Then.
Okay. Fine. Yeah. Okay. I will do that. Yeah.
That will be probably the easiest. Okay. Let's
do
that.
We'll do that.
So let's go down to the second one. This is bulk water we are talking about, at 150 liters a day. But we only drink, when we drink water, we drink only 2 to 3 liters a day. And that water is very important for our health. That's why people pay 50 rupees a liter for it, like in India, Himalayan. If you get Evian, then you have to pay 150 rupees a liter, of course. But 50 rupees a liter is what we pay for mineral water. Okay? But can we get mineral water to people in India? I mean, it's a phenomenal kind of thing for their health. One would imagine, no, if the water situation is so bad, you can't. But that's not true, because you only need 2.5 liters. Whereas it's 150 liters I've taken per person per day, and it's going to be probably less than that with a huge population. For bulk water, for drinking, you just need 2 to 3 liters a day. Okay, so let's go ahead. So we are looking now at aquifers under forests, subterranean mineral water for urban centers. So water for health is what we call it. Next one. Okay, so natural mineral water is more beneficial for health, you'll find, than any insurance you can buy, because the basic thing that the body needs is that water which is actually rich in minerals and nutrients. Okay. And that is what natural mineral water has. And you don't know how many things there are, because this has co-evolved with us, as I said, through the history of 3 billion years almost, or at least on land history, which is much less, but 500, at least half a billion years. Okay. So we need health and not hospitals, right? I mean, everybody wants to talk about hospitals, but that's not what we need. What we need is good water to drink. Can we do that? Seems impossible, but we'll just see. Next one. So what is mineral water? See, spring mineral water, which we are used to in the West, is something which we are used to in the mountains in India, at least in the foothills. Rain falls on the forest floor, it assimilates nutrients, and then it percolates down to the mineral base and assimilates minerals and flows out in the spring. What about subterranean mineral water? Well, rain falls on the forest floor, it assimilates nutrients. It goes through the mineral base, assimilates minerals, but it gets stored underground. It doesn't come out in the spring. That's the only difference. So, as a matter of fact, you'd be surprised that the Borivali National Forest in Bombay, which is called the Sanjay Gandhi National Park, 100 square kilometers. The Bannerghatta Sanctuary in Bangalore, 100 square kilometers. These things can actually give you that 2.5 liters of water per day for everybody, even in a 10-20 million city. Not in Delhi, the range, because the Delhi rainfall is low. Bombay gets almost 4 or 5 times the rainfall that Delhi does. Bangalore gets 1.5 times, but it has a much smaller population. Not much smaller, but at least 12 million. But you can do this even in these huge cities. But in the other towns, it's phenomenal what you can do, because all along the Eastern Ghats, Western Ghats, all the Aravalis from Rajasthan, Delhi to Rajasthan to Gujarat, Rajasthan, which is a parched desert state, can give mineral water to almost every city, almost free of charge, instead of 50 rupees. So next we'll see what it is. So that is what mineral water is. Okay, now how do you get it? Next one, please. Okay, so this is a nice picture of somewhere. I think it's in the Eastern Ghats. Okay, okay, let's go easy. So oops, no, that's all right. The first one was just to show you this one. After, no, let's go back. Let's go back a little bit. No, we need to go not forward but back. Right. So again, it's exactly the same thing. It's recharged naturally by rain. Okay. Then you monitor the water because you have to see is its quality good. At most, you have to filter it. Most of the time, the quality is excellent. We've looked at this from places in Telangana to the south near the forest in near Kanyakumari and the Delhi Ridge and the ridge elsewhere. You test it, then you withdraw, and again you have to withdraw only a small fraction of what is recharged. You can't withdraw everything, and then you dispense it through a public distribution system. You store it and dispense it like you dispense milk, so that there are no plastic bottles. People come and take it either in their big bottles or they bring their own whatever containers and take it away, so that at least the plastic which is coming off water bottles, which maybe is 20% of the total world plastic output or pollution, can be stopped. So that is the idea. That is again just the flow chart over here. And then it's recharged again the next year by rain. And again, sitting over there. But because it's 2.5 liters, you can do this in many, many places. Okay, next one. So what are the great advantages? The so-called mineral water, rupees 50 a liter, it's transported from a faraway mountain spring, puts ecological pressure on the mountains, it gives a lot of greenhouse gases in transport, non-local, not possible for all cities, packaged in plastic, ends up in landfills. Okay, RO water, it's demineralized, no nutrients, pH low, and a lot of it is wasted. So these are the things that we can get right now, the best to the people. If you have an RO unit installed, if you don't have it, then you're going to have to drink water which is polluted, which is what is going to happen with the government scheme. Next one. So this is just to say that the WHO recognizes this, that demineralized water can have unsatisfactory properties and an adverse influence on both the animal and human organism. Next one, I've already said this, that 80% of our surface water is polluted. Okay, next. I don't worry, I'm just about to finish in very soon. So here's a chart which you can share this presentation. And you can see that these are avian, Fiji, Perrier, Himalayan, Kwa, Catch, Mountain Spring, that the water that we get from the ridge where we tested is about the same quality. Okay? This is a chart. This is testing. Okay. Next. We're running through to the end now very quickly. So if we cut down the cost from rupees 50 per liter to rupees 5, okay, and then you don't have to spend what people are spending $100 on supplements and multivitamin minerals and so on and so forth. It can give you actually incredible health, and there is no wastage. Next one. No plastic, no pollution, and dispense from booths. As I've said this already, you have a private public partnership. We tried to do this in Telangana, almost did it, till the government said that we've already given a guarantee that there's a scheme Bhagirathi which we spend I don't know how many thousands of crores, and if we tell them that this is water for health, then they'll think that the other water we're giving them is not healthy, which we know it's not, but it would be terrible politically, so they didn't do it. Right, we went right to the end in a place called Salem. Okay, next one. So this is just a little thing from Borivali National Park near Bombay. And the next one. And these are things. In Delhi, we have, oops, sorry, just go back once. We have this. In Bangalore, I told you. And in Visakhapatnam, we have, and this is where we took the water and tested it just next to a forest in a small town. And all you need for 120,000 people is 3 square kilometers of forest. That's all you need. So any place which has that much forest can actually produce mineral water. Okay, I am done with this, and I just wanted to show you, I told Sid that we had used these ideas to produce something which you can get on the internet if you type out, next one, if you type out, all right, so all the good things that you have, non-polluting, non-invasive, perennial, local. Okay, next. Okay, if you type Amravati Natural City, you will get this picture with the Buddha sitting there. So some work where these solutions are used for a blueprint for a natural city. I mean, some other time when we do this, I'll talk about what natural cities and natural habitats can look like. So the idea is to build a city on a completely different principle of being self-sustaining, like a living organism, self-organizing and self-sustaining. And Siddharth ought to know that, because if he's working on complex systems, this is what complex systems do, like us. We are self-organizing and self-sustaining and throughout. And we make the city self-sustaining on water, food, milk, and climate. And so it saves a lot on energy, and it is, I haven't shown you the thing, but one is like a chessboard pattern in which, the black squares are the forest areas or the pasture lands, or where you grow agriculture, and the white areas, the built-up areas, 1.5 kilometers square. And that's what we gave for Amravati, which was a new city in Andhra. Again, it was proposed by Professor Swaminathan from the Swaminathan Foundation, and Professor Leggett, who's been a Nobel laureate, but the Chief Minister did not do it. So please see our site if you want to do that, and if you want to work on any of these ideas, please, you're most welcome to contact us and do that. Now, the last thing is the next one, is a book I've written, which actually is an interesting book. But I thought I'd just talk about it because of the fact that it takes you right from the beginning of the planet to who we are and how we got there. Okay, how everything works in nature, and then what we've been doing, which is messing it up, and how we can actually redeem ourselves in the future. And instead of looking for your personal fortune and then thinking, some of us think about the society, those have to be great reformers like Gandhi, and nobody thinks about the planet. If we did it the other way around, that if we gave priority first to our habitat, which is planet, then second to our society, which is very inequitable at the moment, and then gave you free rein to make your fortune or whatever you want to call it, we would be running in a very different way. So this is available with HarperCollins. And I'll stop there. So we can handle some questions or whatever, I know, but I also tried to finish reasonably fast. So anyway, if you have some questions, these are two pretty simple things, but they are things that can be used anywhere in the world.
Thank you, Professor Soni. Sid, how do you want to, I mean, I think the questions, my personal thought is let's have the questions in chat for now, and then if Professor Soni is around, which he's going to be, he can answer them in chat, or we can have a live Q&A at the end of the next talk, because the next speaker is waiting for some time. Yes.
Thank you, Samit. I think we have to go to the next talk, and my deepest apology to Professor Suresh for waiting for so long. Due to technical glitches, we had this long